Hello, my name is Isaiah. I received my master's in environmental science and management from the Bren School at the University of California, Santa Barbara. This summer, I had the great pleasure working alongside Brendan to complete Bristol Seafood's first comprehensive life cycle assessment. Today's focus will be on their two biggest supply chains, their Norwegian haddock and Japanese scallops. By taking this first step, Bristol will have a greater understanding of their environmental impact and be able to take action to reduce it. So diving in, this first graph displays the environmental impact of their supply chains normalized to their baseline haddock scenario and includes an added alternate haddock scenario. Their baseline scenario is the normal assessment, while the alternate one is largely the same but increases some of their operations in Norway. We made this comparison because the Norwegian grid mix is largely renewable and runs off of hydropower. As we can see under the alternate scenario, both freshwater and marine eutrophication impact was reduced by almost a quarter, which is great for the health of aquatic organisms. And we've seen improvement in land use as well. There is, however, a non-negligible increase in water use, which stems from the hydropower. Some pretty significant changes in most of the impact categories. It's somewhat disappointing that the greenhouse gas reduction is so minimal, but that's one of the great things about LCA. You can have these thought experiments and assess trade-offs. And in the next slide, we will see why the greenhouse gas reduction is so minimal. So looking at the greenhouse gas impact, most of it comes from the ocean transit and harvesting portion, with the US electricity barely showing up at the bottom there. But again, even mitigating that portion had some significant benefits. But what can we do about the greenhouse gas impact? The harvesting piece is a lot harder to tackle. That would involve a lot of policy centered around things like fisheries management to increase stock, which would reduce the time at sea and lower energy expenditure. Ocean freight, on the other hand, can be mitigated much quicker. The vessels that the product is being shipped on are relatively small compared to other cargo ships. If we can find a transporter with larger vessels to ship it, it could greatly reduce the impact. Reason being, if you're transporting, say, 2 million pounds of product along with 200 million pounds of other goods, your share of the impact is a lot smaller, which is why I decided to fly commercial. Moving on to the next slide, our scallop supply chain. We see that the harvest portion is almost non-existent. That's because the way they harvest is a lot less energy intensive since they don't have to be out at sea for as long. Their ocean freight portion is fairly small compared to the haddock, especially when you think about how the journey from Japan is 2.5 times further. That's because they're being transported on much bigger vessels, going back to what we were talking about before. You see how electricity and processing aids are responsible for most of the impact. It could be beneficial to generate some electricity on site with solar PV. As for the processing aids, we identified the culprit responsible for the large impacts, which opens up the possibility of finding alternative aids that don't contain that ingredient. And I'd like to give a big shout out to my mentor, Brendan. Gathering such extensive data across the globe in a short period of time is not an easy feat, and I wouldn't have been able to do it without him. Thank you.